Welcome back to Life with Miss H. We're going to look today at solving systems, really just kind of solving equations and then also getting into systems. Basically what a system would do is show you a point where two different equations cross, like if you're looking at two different companies, Verizon Wireless and AT&T, where their equations cross at would be the point where you pay the same amount for X amount of minutes, the same amount for a plan, and then also it can show you at what point would it be better to use one company versus the other. What you have to keep in mind when you're dealing with systems, there's types of solutions. You would have one solution where X equals a number, so you get down to just like X equals one specific number. They'd be infinite solutions, like your X will cancel out, your variables will cancel out, and then you're left with like 1 equals 1, 3/4 equals 3/4, -2 equals 2. All of those are true statements, so that would be any number you plugged in for a variable would work out. And then you also have like a no solution. That would be when you get down to 5 equals 6, -2 equals 0. Neither one of those are true statements because 5 doesn't equal 6, -2 doesn't equal 0. So that's kind of what you're looking at. We're going to work a couple examples together. The very basic one is where your variables are on different sides. Treat them like any other equation that you would solve. I try to avoid negatives if possible. So I would bring this plus 2y over. So bring my negative 2y over by adding 2y. It cancels out over here, leaves me with 1 equals y plus 2y's is 3y. And then this -5 just drops down. And now I've got a two-step equation like you're all used to working in 7th grade. You're going to add 5 across. That leaves me with 6 equals 3y because these will reduce down to 0. And then divide by 3. 6 divided by 3 leaves you with y equals 2. So that would be one solution. Next example. There's nothing to do on this side, so I just get 7x minus 11. And then I want to distribute my 5x, -10, and then this part just kind of drops down. So these are multi-step equations. 7x minus 11, I'm still not doing anything there. And then I could put 5x with 2x, that's going to give me 7x. -10 and a -1 is -11. And then if you notice, I've got the same amount of x's. So when I bring the 7x over, that's going to eliminate on both sides and leaves me with -11 equals -11, which is a true statement. So therefore, this would be in your infinite solutions. If this was to reduce down, and for instance, if this right here was like a -5 instead of the -11, you would have been looking at -11 equals a -5, so that would fall under the no solutions. But where those are the same, that would be infinite solutions. So that is kind of how you're going to look at when you only see one variable and they're the same variable. That's kind of how you work with them. Now you're also going to get to some examples that require you to have two variables to look at. So now you're looking for an exact point. The problem that you have, if you're working on the handout that I left you, you've got x plus y equals -3, x minus y equals a -5. And there's really three ways that you can solve these: graphing, elimination, and substitution. Before you all left and went on the NTI days, we done a lot of graphing in class. That's one thing that you can do, but you have to have y by itself. These other two, you don't necessarily have to get a specific variable by itself, and when we work on elimination, you're going to see you don't have to get anything by itself at all. But to graph, I want y by itself, so to get rid of a x here, I'm going to subtract x over. That's going to leave me with y equals negative x minus 3. So I can graph that as negative 3. To get your negative slope in, you're going to go up and left, up and left, up and left, up and left. So for each time, you're going to go up one, left one, up one, left one, up one, left one, up one, left one, and that draws in a nice straight line with negative x minus 3. Shifting over to the next equation in the system, x minus y equals negative 5. You're going to treat this the same way. I'm going to subtract x over. Gives me a negative y equals negative x minus 5. Divide by a negative 1 to get rid of that negative with your y. That's positive y. 2 negatives make a positive x. 2 negatives make a positive 5. So my second equation would start at a positive 5. And then to get your positive slope, even though you're used to going up and right, I need it to intersect this line, so I need to work backwards with it. So a positive slope, if I go down and left, that's still going to give me a positive slope. And if you notice, the two lines meet at point negative 4, 1. So at the point negative 4, 1, that would be the solution to the system. All right, that's one method that you can use. Second method is elimination. Even though this is another method, you don't necessarily have to use it. The goal with elimination is to have the same amount of a variable with opposite signs. So you have to have opposite amounts. So like a 2 and a negative 2x, negative 5y and a positive 5y. So those would eliminate. So if you notice with this system, I've already got a positive 1y and a negative 1y. So when I combine these through addition, that's going to leave me with 2x. Your y's will cancel out and leaves you with a negative 8. I want to divide by 2. X equals negative 4. And if you remember back to your the solution to the graph, it crossed at negative 4, 1. So in my solution, I know that my x value is going to be negative 4. Then to get my y, I can plug into any of these. It don't really matter. I'm going to pick the first one. The x plus y equals negative 3. I'm going to put negative 4 in. I want to add 4 across. That eliminates, leaves y by itself. And a negative 1 plus 4 is a positive 1. And you get the point negative 4, 1. So if you look back, that's the same solution that I got when I graphed. Just a different look. And then finally, you could do substitution. This one requires you to be able to get a variable by itself and then plug it back in. It don't really matter which one you start with. I'm going to use this one, and I'm going to get x by itself. So I'm going to pick this equation. I'm going to get x by itself by adding y across. And I get x equals y minus 5 because I can't put y's and non-y's together. So I'm just left with x equals y minus 5. So what I can do, I can bring that over and plug it into this equation for your x. So I want to have, instead of x, I want to have y minus 5 plus y equals negative 3. That's going to combine like terms to leave me with 2y minus 5 equals -3. Add your 5 across. Gives you 2y equals 2. Divide by 2. And you get y equals 1. So when I start building my final point, you're going to get y is 1. And then I can bring this y into either this equation, or this new equation to get my x. It don't really matter. They all require just a little bit more work. Like for instance, where this already has x by itself, once I put y in and simplify, I'm done. Up here, I would have maybe a 1 or a 2 step equation to work. So I'm going to take my x equals y minus 5. So I'm taking this equation, and I'm going to put 1 in for y. When you do 1 minus 5, you get a -4. So you're left with x equals -4, and you're back to the same solution. So if you kind of look, I've got 3 different looks. All of them leads me to the same answer. So when you're dealing with systems and you're trying to find that point of intersection, or if their lines run parallel, or they give you the same line, it really doesn't matter which way that you use. You can use graphing, elimination, or substitution. You're all going to get the same exact answer. One may require a little bit more pre-work than the other. For instance, with my class, a lot of you all would probably pick graphing, but you have to make sure that y is by itself. So that's kind of your key there. Make sure y is by itself before you start getting into the graphing part of it. Hopefully this helps. If not, reach out to me. I don't mind to work with you on problems that I can, or really any of them. I don't mind at all. Be sure, as you're viewing this, subscribe to Life with Mrs. H. Good luck, and I'll talk to you all later.